Okay, guys, so without further ado, let's go ahead and start. This is week 2 of the second quarter, the second 9 weeks, and still in, so halfway through semester 1. Halfway through semester 1. So this week's topic, it's pretty basic. Should be review for you guys, but I do want to take the time and go over it. I want you to title it Relations, Functions, and coordinate geometry. Okay, so it sounds pretty, like, overwhelming, but it's not. This is, like, Algebra 1 stuff. So, it's going to be an easy week. So next week we'll do, we'll do quadratic equations, but this week is mainly going to be linear equations, but next week, and then even probably the week after, that's the goal, would be quadratic equations. So this is this week's topic, linear equations. So without further ado, let's get some vocab done. Let's get some vocab out of the way. So, domain. All possible x values. Range. All possible y values. Okay. Where's my highlighter? Okay. Domain, range. Okay, so for example, say I have a set of points four comma 2, 3 comma -1, and 6 comma 10. Say I have these 3 points, so then the domain, which is talking about all the x values, it's going to be 4, so it could be written as d equals 4, 3, 6. Then the range, you could be written like this: 2, -1, 10. Okay, very, very straightforward. Let's see here. So now let's move on to the difference. So I think I have any room. Let's move to the next page. Okay, relation. any set of points which connect to variables. I don't really like that definition. So there's relation and then there's function. So guys, math is all about relationships. Believe it or not, it's all about relationships. It's all about pretty much how to relationship. I'm gonna have to live with that. It's all about pretty much how to describe, how to put in math language a relationship between any two objects or any two like ideas. So for example, like a really, really classic example would be like the relationship between time passed and distance traveled. Okay, so two items, two ideas, and then the whole idea, the whole concept of math is putting it into something like an expression, an equation, something that like is expressed using numbers and variables. So there's two types of, so there's relations and then there's functions. So you could think of relations as kind of like an open-ended relationship. Or I don't want to say open-ended. Let's just call it, I mean, that's what they are. They're open-ended. But let's just call it, just for easy, an open relationship. Okay, so in this open relationship, there's no rules. Okay? So you can date whoever you want, and they can date whoever they want, and they can flirt with other people, and you can flirt with other people, and it's really all just a huge hot mess. Sooner or later, without some type, I mean, unless that's what you want, sooner or later, someone is gonna, after whatever amount of time, a situation's gonna arise where someone's feelings are gonna get hurt. And so a relation is kind of like no rules, almost anything goes. Kind of like, I don't want to say friends with benefits, but I mean something along those lines where you can see whoever you want, and they can see whoever, and they can flirt with multiple people at the same time, and you can flirt with multiple people at the same time, and you guys are dating other people, texting other people, flirting with other people. So there's kind of like a no, it's not exclusive. There's no like I don't want to say like there's no like, there's just not really that many restrictions on a relation. Okay, and now you can think of functions. You can think of functions as an exclusive relationship. Okay, where two people, they have, there are certain things that they can't do, that they don't want to do with other people, so they're only focused on that one person. Okay, and exclusive. So there are rules. So there are rules that the other person has to that they both have to respect for it to be considered an exclusive relationship. So you can't just go around flirting with other people. You can't go, I mean, because you decided to be exclusive. So there are rules that come with that. But the bottom line is, in math, okay, so let me get my highlighter. There it is. In math, guys, no rules. Okay, and now a function, oops, let me undo that. Let me make it green. Now a function is there are rules, okay? There are rules to a function. And it's the same thing with math. Okay, relations, there really are almost no restrictions, nothing that either data set has to respect or abide by. And then there's functions where there are rules that need to be followed for them to be considered a function. Okay, so kind of like that. All right, and so moving on to the next page, because it doesn't want to, oh my gosh. God. Okay, here we go. All right, that was a very, very brief example. We're gonna talk about, we're gonna talk about actual, like, concrete examples in just a second. Okay. But for now, so let's make sure that you know all your basics. So this is a coordinate plane, right? This is your x-axis, that's your y-axis. It's your origin. You should know that. This is your first quadrant. It goes counterclockwise. Second quadrant. Third quadrant. Fourth quadrant. Okay. Everything in here is positive. That's negative, positive. That's negative, negative. And that's positive, negative. Ouch. What else do I want you guys to know? Moving on. Okay, here we go. You should also be very, very familiar with the concept of the vertical line test. So imagine like a graph, right? And this is the function. This is the, well, we're on a plane, and that's the function. So imagine a vertical line. That's your vertical line. And it kind of scans the entire graph. As long as it hits the graph only once, like this is a function because it passes the vertical line test. Okay, but now let me give you a counter example. Say I have, go to the next page. Say I have, this is my graph. No, I won't block. This is my coordinate plane. That's X, that's Y. Okay, say my graph looks like this. It's like a sideways parabola. Let's take the vertical line test. That's your vertical line. It's going to scan the entire, kind of like a barcode. Okay, so scanning. So right here, it passes. Okay, but what happens when you draw a vertical line like right there, or right there, or right there? So here, it hits the vertical bar twice. Here, it hits the vertical bar twice. Here, it hits the so at multiple points, this red sideways parabola is not a function. It fails the vertical line test, okay? So it is not a function. Alrighty. Moving on. So vertical line test is very important. Vertical line test. Easy way to determine if it is a function. If what you're looking at is a function. If it fails the vertical line test, it is not a function. Alrighty. What else? So, you should also be very fluent. So, you should know this notation. It's the same thing as y equals. Alright, this is called on the left. This is called function notation. The F, that's which stands for function. F for function. So this reads as a function of x. Function in terms of x. But we always just write f of x. So you should know exactly what this means. That it's just another way to say y. And what else do I want you to know? No. Moving on. Alrighty. So. A linear function. Okay, you've seen a lot of these in Algebra 1. It's been a long time now. Next page. Linear functions. Let's talk about linear functions. This is the form of a standard linear function. So in this scenario, also known as M, aka M, aka slope, aka rise over run. And then there's the B, which everybody knows is the y intercept. Okay, and x is just the variable. Okay. Oops. Not green. This x and this x, you don't really mess with them. A and B, also known as M and B, these are the magic pieces that determine what different linear functions look like. And so A can be a fraction. Most of the time it is. A decimal. It could be positive, negative. It can be 0. Alright, same thing with B. There's really no limit. The only B can be 0. Again, it can be positive, negative, decimal, fraction. Okay, alrighty. So, and obviously linear functions. This is your coordinate plane. Okay, a linear function. It's very, very easy to tell if something is linear. Is it a straight line? Always, if there's a curve to it, it's not linear. If there's a corner to it, it's not linear. So it has to just be a straight line. Very, very easy to determine if something is linear or not. So you know how to determine if something is linear based on the format. This is your magic format. Okay. You know what each part does? Alrighty. So, very quickly, example. So this should be easy review for you guys. Say if you have a function 2x minus 3. It's a linear function, right? Your a, also known as your slope, is positive 2. And then your b, also known as your y-intercept, is negative 3. So this is linear. It has a slope of positive 2, so it's going in kind of like an uphill direction. Imagine a guy and he's kind of going uphill. So that's how you can kind of tell if something is positive or negative. So if the slope is positive, it's going uphill. There's a increasing. The y-intercept, it just tells you where it hits the y-axis. Okay. I'm kind of flying through this because I know that you know most of this. I had like 95% of you guys last year. I know you know this, but I do have to teach it. Okay, so just very quickly, if a problem asks you find f of 5, what is f of 5? All they did, if you notice, all they did was they replaced x with 5. So they're telling you what to do. They're telling you to just replace x with 5 so that your problem now looks like this. Okay, so that's simple, like, evaluations. You need to know how to do that. You need to understand what this notation means, what it's telling you to do. Obviously, they just replaced the x in the original problem with a number. So they're telling you what to do. Okay? So say I have, I'll do another one. Say I have a function let me do 5x minus 4. And it wants you to find f of negative 2. So again, it's telling you to replace x with negative 2. So then f of negative 2 is 5 parentheses negative 2 minus 4. So that's negative 10 minus 4. So that's negative 14. So you are going to see notation like this. You should know what they're telling you to do. Okay. Domain and range. natural domain. A lot of this I have another video for, so I don't want to do that. No, don't want that, don't want that, don't want that. Definitely not that. Let me go. Okay, so now I want you guys to, well, you should know. Next page. You should know the slope formula. Very quickly, it's y2 minus y1 over x2 minus x1. You should know that. I'll do an example. Actually, I have another video. I'm going to link both videos. So, given 2 points, x1, comma, y1, and x2, comma, y2. So these are just 2 coordinates. So this is point 1, this is point 2. Okay, so I just named it based on the point. Okay, so it's just a very simple computation. I'll do one example. Say I have 4, 10, and -6, -9. So first thing I want to do is I want to label, that's my x1, it's my y1, it's my y2. Once I've labeled everything, because remember, every coordinate point always has an x, and every coordinate x is always first, and every coordinate point always has a y, and y is always second. Okay, so now I'm just going to plug everything into the formula up here. y2, so y2 is -9, minus y1, which is 10, over x2, which is -6, minus 4. Now I'm just going to compute it. That's -19 over -10. Let's simplify a little to get 19 over 10 as my slope. I can no longer simplify that. Okay, so finding slope is very simple. Again, I am flying through this because I know that you guys are really, really strong in this area. To find the y-intercept, you really just have to, like, look at the graph, and then you can easily identify it. What else do I want you guys to know? Ouch. Linear functions. You should be aware, you should know what an XY table is, given certain values. Right? Given, so whatever x values you plug in, let me actually put, there we go. I'm going to put this instead. Okay. So, 2 parentheses, -3 plus 1. 2 parentheses, -2 plus 1. 2 parentheses, -1 plus 1. 2 parentheses, 0 plus 1. 2 parentheses, 1 plus 1. 2 parentheses, 2 plus 1. All right. right, so that's negative 6 plus 1. That's negative 5. Negative 3. Negative 1. Positive 1. 3. 5. So if you do not know how to formulate an XY table, please just email me. It's very straightforward. So there's XY tables, and then there's domain and range. And I do have a video for domain and range. I am just going to link it. I mean, really, that's it. I would ask you to graph things, but you guys are at home, and I can't. So just as long as you guys know that so that would be a positive. So that would be your y-intercept. Anything intersecting the x-axis, this is known as the x-intercept. X-intercept. Y-intercept. All right, and so let's zoom in. So say if I have a line and it goes like that, I can connect the dots. Oh God, that's horrible. Okay, whatever. All right. Okay, so it's very, very simple to, given a graph or given a line, you can easily identify the slope. Intercept is extremely simple to identify. You just look for where it intersects the x or y axis. But for slope, everybody knows it's rise over run. All right, rise over run. So I can just pick any point I want. And how many do I go up? So that's 1, that's 2, that's 3. So that's 3. I've risen 3, gone up 3. Oops. Let me actually rise over run, and so I've gone up 3. I've gone up 3. So this is the original point, right? So 1, 2, 3. Then I have to go right just 1. Right 1. Up 3, right 1. And so my slope, in simplified form, of this line is positive 3. And then wherever it hits, so like, oops. So notice how I'm doing that. One, 2, 3, and so I go the exact opposite, down, left, down, left. So now I have lots of points. I can easily connect them to form that's supposed to be a straight line. And I mean, you guys get the idea. You guys are very smart. Okay, so just watch out for a few problems due at the end of Sunday night. So Sunday, 11:59 p.m. And I know this was painstakingly boring and old information for you, but I do have to go over it. Like I said, I am still working on that foundation for you guys. So please just email me if you have any questions. The problems should be pretty straightforward and simple this week. Again, I'm sorry if I kept you guys waiting. Thank you for being so understanding. And just email me as usual if you have any questions, but I will see you guys later. Okay, bye.